Often these are represented by like a pendulum or some type of shape of a pendulum or a circle, right? Because a circle, when you draw a circle over time, it makes that sinusoidal graph, which we've done before. Remember, we drew the unit circle to get the cos graph, and we use the unit circle to get the sine graph, and even the tan graph, and that's how you got the cyclical sinusoidal wave for sine and coses. So that's what we're going to do. So this one's a Ferris wheel. Now, there are some Ferris wheels probably in this world where you start on ground level, okay? If it was that you got into the Ferris wheel and you sat in an object where your legs weren't hanging. However, if you're on a Ferris wheel and your legs are hanging, they're probably not starting you on ground level, or every single time you're going around, you're getting your legs ripped off or you have to lift your legs up. So when people always tell me Ferris wheels start at 0, it scares me sometimes. So we have to do real life examples, and we kind of think, would this Ferris wheel possibly start on the ground? Or maybe there's a chance that there's actually a bottom of it, a base of this Ferris wheel, where I'm not getting onto the Ferris wheel down there. I actually have to step up and get onto a Ferris wheel, right? So my legs don't get ripped off as I'm going around. You know, these fun things. So often people will start me at 0. So we don't want to be those people. Okay. So, but like there could be a Ferris wheel. Don't tell me I could be wrong. There could be a Ferris wheel where you get into like, you know, like the ones at Callaway Park where you get into like a balloon. It still is off the ground a bit, but they could have been started that one on the ground because you get into the physical balloon and your legs aren't hanging. You know what I'm talking about? Yeah. Okay. So we have some people start them below ground. That's always like when I get a minimum at like -3, I'm like that. I've never seen a Ferris wheel go underground, but maybe. I could be wrong in this world. There very well could be one. I think we should use the Google and see. I actually want to know right now. I've been standing corrected. California Adventure. This is what we're talking about. You walk below ground to get into. See, I knew there had to be someone who made it, but why? What would be the point of making it below ground? For fun, for it to be cool. It looks better. I think that would be the only time I would enjoy the part of the fair. I'm still recording. When you're underground, like when you just hit like that, be like, oh. And then you start going back up and I see the height, and then my height scaredness part of me wants to like, and they will stop me at the top, and then it's always like gusty winds and then it's blowing and rocking, and I'm just like, I hate Ferris. Makes me cringe talking about this one, but whatever. It's good. Good times. The height of a rider on a Ferris wheel is given by that. So that's the rider going around, correct? It's not the actual Ferris wheel. It's dude on the Ferris wheel going around the Ferris wheel. Yeah? H of t is the height of the rider after t seconds. So h of t is the height of the rider. So we always want to know, because they have to tell us what the variables represent when they give us variables. They can't just assume we know what they are. And then the t is the time in seconds after the rider gets onto the Ferris wheel. We agree? So what are the maximum minimum heights of this Ferris wheel? Do we actually have to throw it into our calculator and graph it? No, off of an equation, there's a really quick way we can figure out the max and the mins. Do we remember? D plus the amplitude gets me the max in D. Okay, so let's find out if this one goes below ground, because I guess they can. I stand corrected. Okay, so minimum is D minus the amplitude, and maximum is D plus the amplitude. Okay. So D is what? 12. Amplitude is what? So this one starts at 2. It should say the height in meters. It really should give, that's just a typo. It should give a unit of measurement, or else it could be centimeters, whatever. So this one starts at 2, and what's the highest it goes and scares me at? So 12 plus 10, so it goes to 22. Yeah, I don't want to go on this Ferris wheel, just so you know. This is not, nope, thank you. I'm good. The balloon ones at Callaway, I'm like, this is okay, I'm enclosed, I feel safe. I like those ones. I will balloon Ferris wheel anytime. Could be a shape of a bird. I'd get, that'd be fine. I just don't like the ones where your legs dangle and the little clasp things on the side are like a semicircle, and like you look at them and it's like wavering like this, and you're like, if it just makes a little bit of a degree more of a movement, it's that little semicircle clasp gonna just, and then I just go. Falling off? That's what I think every single time. That is my little brain going around. I'm going around. I'm like, it's getting closer. It's getting closer. It's getting closer. Oh, it's back. It's getting closer. It's getting closer. Oh, it's going back. That's what I think. That's the joy I have on a Ferris wheel. Now you might think that too. I hope you enjoy that. All right. How long after the wheel is at its lowest point does it reach its highest point? Now, circles, when I start at the bottom of the circle, or the top of the circle, wherever I start, you can be transported to the top of the Ferris wheel by a helicopter. That would also not be a good option for me. I do not want to go in a helicopter. Anyways, start at the bottom, and we go all the way around, and we come back. So it's called one revolution, right? One revolution of that Ferris wheel or that circle or whatever it is. What word have we used for a definition in this unit that could possibly cover that one revolution? Period, right? So if the period would be one revolution, right? So whenever they say one revolution is every 30 seconds, let's say, they're telling you the period is 30 seconds. They're being nice. Okay? So they ever say, how long does it take for it to do one revolution? They're really just asking you to find the period, right? One revolution, period, same thing. I'm going to write that a little side. One revolution. Now, if we look at a Ferris wheel as well, we'll come back to B in a second. If we look at a Ferris wheel as well, this one has a little base. Okay, it starts at 2. It goes to 22. What was my amplitude? 10. And my amplitude is half the distance from the min to the max. So it's 10 and 10. We agree? What's another word for amplitude that they could use in a word problem? Radius. So these are fancy word problem words for amplitude and period. Okay? Now so this is what happens. People tell me, they get all of this right, and then they tell me the midline's at 10. Well, you're going to know the midline's not at 10 because the D value is your midline. The midline's 12. But they'll tell me it's 10 because they forget that there's a base on this, right? Where is the actual midline of this Ferris wheel at, as opposed to the ground? It would be 2 plus 10, so it would actually be at 12 meters would be my midline, right? So you also have to remember that if there's a base, you have to count the base and the radius to get me to my middle of my Ferris wheel, because I want the middle of the Ferris wheel. So B says, how long after the wheel is at its lowest point does it reach its highest point? So lowest point to highest point. What's another word for that in our fancy words? Half of the period, right? Half of the period. Now, we have an equation. How can I find the period? 2 pi over b. Now, word problems are in radians. They don't make sense in degrees. Okay? So it's going to be 2 pi, because if not, if I say the period was 180 degrees, does that make sense? Go around a circle in 180 degrees. Does that make, never since life have you've always been told a circle's 360, a circle's 360. So word problems only make sense in radian measure. So we want to find the period, which is 2 pi over b. What is b? Pi over 30. So we're going to get 2 pi divided by pi over 30. And whenever I have a division of fractions, I write it sideways. So 2 pi divided by pi over 30, or 2 pi times 30 over pi. The pi's cancel, and I get 60 seconds. Technically, this baby repeats itself every 60 seconds. So is that the answer? Yeah. So that's not the answer to this question. That's how long it takes to repeat itself. They want from min to max. So it's actually 60 seconds divided by 2. So it's 30 seconds. How long does the Ferris wheel take to make one revolution? 60 seconds. We did the work already. During 1 minute of the ride, at what times after the rider gets on the wheel, is the wheel at a height of 20 meters? So first off, we have to decide, did they give me y, or h of t, Or did they give me x, which is t in this case? Did they give me y, which is h of t? Or did they give me t, which is x? They gave me y. So you could do this algebraically, which we will, and then I'll show you how to do it graphically. Okay? Best to have two ways, because what if one doesn't work? At least you have a backup method here. Okay, so we have h of t, and this one's going to be a little bit awful. H of t equals 10 sine pi over 30. I can't remember what the rest is. T minus 15 plus 12. Now, why is this going to be awful to solve? If they give you t, it's really easy to solve, right? Fill in for t, this bracket put together, take the sign of that bracket. You just have to make sure your calculator's in what? Radian mode. Okay, the moment you press that sine cos tan button, you have to make sure you're in a proper mode. This can be a lot harder because we have to solve for that t that's inserted in there, right? So most people will choose the calculator way if they have a choice. I'm going to show you both anyways. So, in for h of t, which is y, which is h of t. And if you don't know which one they gave you, look at the units. The units at the top were meters, right? And then they give me 20 meters, and h of t was in meters, so they gave me h of t, right? So we have 20 equals 10 sine pi over 30 t minus 15 plus 12. So technically, this is all attached together, correct? So what's the first thing I need to move? 12. I'm minusing it. So now I have 8 equals 10 sine pi over 30 t minus 15. Does it sound like this is going to be a great way to go about it? Divided by 8. 10. It's a really bad way to go about it, actually. Divided by 10. Now we got fractions to make our heart sing. 4 over 5 equals sine pi over 30 t minus 15. At this point, people are going to put in their calculator because they're like, no, thank you. No, thank you. So if you're given y, some people are like, I can never get the window to work. You can get the window to work. You know what your minimum is. You know what your maximum is. You know how long it takes to repeat itself. You have a window, right? So honestly, when you have a word problem, those are the easiest windows to make. Anytime you're given an equation, it's really easy to come up with the window. D plus amplitude gets your max, make it a little higher in the y. D minus amplitude gets your min, make it a little lower in the y. Your period, I always do twice it. So in this case, the period is 60. So I would go from 0 to 120 myself because I like seeing 2 rotations. Sometimes they might ask you to the 3rd rotation of the Ferris wheel, but usually it's within the first 2. So that's what I do. So we're going to go that route because I don't know anyone who's going to choose this route. When it's t, it's really easy, right? You just punch it in all into one thing and bam, you're done. Make sure you put the brackets the same. You're golden. Oh, actually, make sure it's in radian mode too, because that wouldn't work if it's in degrees. So, most people at this point would go y1, y2 anyways and give me all the answers, because you're going to get numerous answers, right? Why would that be? Well, you have a graph that looks like this. At 0, we started at 2, right? And we go to 12, and we go to 22. So technically, you're going to get a graph like this. At 0, you started at 2. Then, because this is a Ferris wheel, how long did it take us to get around this Ferris wheel? 60 seconds. So how would I find it? So this is going to be at 0 seconds, 2 meters. How can I figure out what this point's going to be? It takes me 60 seconds to get around the whole thing. This is cut into how many? 4. So what's 60 divided by 4? 15. So at 15 seconds, I'm going to be at 12 meters. Then at 30 seconds, I'm going to be at 22 meters. Then at 45 seconds, because these are just coordinates, right? I'm going to be back to 12 meters. And then at 60 seconds, I'm going to be back down to 2 meters. And I could keep going on for life. This baby just keeps going, right? So that's why when they ask me something like this question, they have to limit me to what, like the first time it reaches 22 meters, the second time he reaches 22 meters, how many times does he reach 22 meters in the first revolution? Like they have to specify, or else you could give new answers forever. This person 2 days from now still just going around this Ferris wheel. Like that would just suck really, really bad, but they could do it. They could. It would not be for me. Just hand you a hamburger on the way you used to go by, you know. I'm curious. What's the longest time someone's been on a Ferris wheel? Use the Google. I will use the Google in a second. Okay. So if I were to sketch this baby, we'd have 0, and then we'd have 15, and this would be in seconds. And we're at 12. And then at 30 seconds, we're at 22. And then this is a really great graph. 45, we're back down to 12. It's even kind of curvy. And then at 60, we're back down to 2, not 0. And then what's going to happen? For forever, right? Now, they want us at what? 20. 20 is about here. So at this time, 20. At this time, 20. At this time, they reach 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 20. And etc. Right? So they want in 1 minute. So a guesstimate would say, I don't know, 20 and 30 something. Right? So if you're getting 705, probably not good. Probably off. Okay? Maybe you're in degree mode if you get this real wonky looking thing. So what I'm going to get you to do is practice putting in your calculator. So you're going to type in your original into your calculator, this one, into Y1. 10, sine, bracket. Now pi over 30, what does it have to be in? Brackets, why? Because it's a fraction. Fractions also go in brackets. So you're going to go 10 sine bracket. Bracket. You're going to bracket till the cows come home at this point. Bracket. Bracket. Pi divided by 30. Bracket. Bracket. X minus 15. Bracket. Bracket. Plus 12. So you'll be bracketing for a while. Get some good use of your brackets. That will be in your Y1. So if we look at this blue equation, this would be in our Y1 with the 12, sorry. And this would be in our Y2. Could we do this? Could this be in our Y1? And this in our Y2? Would we get the same answers? We should. The X values. The Y values would be different, but who cares about that? Could we move this 20 over, make it join the 12, and make it be -8, and make Y2 be 0 and find the X intercepts? Yes. You still get the same answer. All the X's will be the same. Remember how I showed you that? This part of the, Okay. So I'm going to make my Y min be 0 and my Y max be 23 because I want to see more than just the little max, right? So Y min be 0, Y max be 23. Then I'm going to make my X max be 0 because it's time and negative doesn't matter. And my X min be 0 and my X max be 60 because I don't want to see any more of the graph. I want to see in the first minute. If I see more of the graph, I might give more answers and I don't want more answers, correct? Now you should see 2 spots where it crosses, right? So second trace 5. In Y1 you have the equation, in Y2 you have 20, right? And you do second trace 5, enter, enter, enter. If you see like a real wonky, crazy going graph, you have it in degree mode and you need to make it in radian mode. Okay? So you'd have to look at all of the ways that it could possibly, like what quadrants it would hit. Because sine is positive in this quadrant, and then all the coterminals.
Oh, so you can't like divide.
No, it would be quite awful. Yeah.
Oh wait. Maybe I did skip.
Well, you don't have the plus 12.
Oh, thank you.
So what do we get for the x's? Or t's, technically. T equals what? 23.9 seconds and 36.1. And they seem reasonable, right? Now, as an added question, I want you to tell me the height. What is the height? To be very simplistic, not well-written question. What is the height at 70 seconds? For algebra, you could just plug it in for the t and solve it, right? So it would be, you'd go 10 equals sine, not 10, what am I doing? 10 sine, just in your main screen, you'd go 10 sine pi divided by 30, 70 minus 15. You could reduce that, but you can just leave it like that, plus 12. In your main screen, you just put that in. When it's t, you know it's really easy to do algebraically. So make sure you're in radian mode and you type it all in just like that, it'll do the math for you. Could you put in 70 minus 15 and actually do the math and put that in? Absolutely. What do you get? 7 what? 7 meters. Now in your calculator, where's the one place you can put x if you know your x value? Second trace value. I'm waiting for all of you. Do it. I'm waiting for something. The trace thing is scary because trace can be decimals off. Whereas second trace value, you literally put in 70 and it gives you accurate. Now, some people it's going to error you. It's erroring you because you're trying to, and I intentionally picked a value that would possibly error you. You're trying to find x equals 70, but your window's maxing out right now at what? 60. Your calculator can only calculate what it can see. So you need to make your x max bigger then. I made you actually have an error for a reason so that you, when you get to a test, you freak out. Like, oh, right, I just make my window bigger. So your window has to be at least as big as what you're trying to find. And then you get 7, okay? Make sense? So right from your equation, I would always find my max and my min and my period so that I can even graph it. Because if you have your period and your max and your min, it's really easy to graph it. Your max and your min get you your y values. Your period gets you how far it needs to be. Because if you don't find your period and you do from 0 to 10 and this thing repeats itself every 300, you're not even close. Or then people just go 10, no, can't see it. 50, no, can't see it. Then they go 1 million. Like you guys like jump from like 50 to 1 million. Like it's like crazy. It's like must make window bigger. I will make it ginormously bigger. That's not always helpful either. So find the period first and then it's really, really easy to actually make the graph. Okay. So what do I want you guys to do right now? I want you to do one thing right now. I want you to be able to get it to show up in your calculator. So this is your new equation. I want you to try and make a window. So get your min, get your max, get your period of your graph, and try and graph it. Okay? Radian mode because it's a word problem. Now, there has to be a specification on this because the hours in a day, and it needs to say since. If I give you time, it needs to give you since something. Since midnight? Since, like, if not, what is 9? Is 9 9? Is 9, like, 21? What is it? Right? So we're going to say hours in a day since midnight. Because if it was since noon, 9 a.m. wouldn't be 9, right? And it would be the next day, and it'd be really weird. But whatever. So does everyone have it in their calculator? Does everyone have it showing up? Okay, nay. So your minimum time would be 0, right? Could it technically be negative? Yeah, if we went before midnight that day, the previous day, it would technically be negative. Not negative time in general, but negative from the start time, right? So I'm going to just start at 0 myself because all this is after. So it would be 0, and then I would make it my X max be at least 7 because that would get me 2 full rotations, and I like seeing 2 rotations until they until they make me, like if they said, oh, in the first 3 meters, or sorry, this first 3 hours, then I would restrict my domain to smaller. I'm going to make it be between 0 and 7. Time is in hours, dt is in meters. I know it goes from 10.9 to 15.9. So you could go from 0 to 18 if you'd like. Or I would just go from probably like 9 to 17, just so I could see just the part I needed. If you wanted to go from 0 to 17, so you could see from 0 meters to 17, and that makes you feel better, go that route. It doesn't matter. Okay? Now you should be able to see it. You need to be in radian mode. Degree mode isn't helpful. Can everyone see it now? Okay. What's the depth at 9 a.m.? So is that T or DT? T. And how many hours is that? 9. So we could plug it into the formula and get an answer, or we could go second trace value 9, enter. Or we could because it's a solid number, we could go to the table of values and look at the y. There's so many options when it's a nice 9. If it was like 9.375, then your best bet is to either plug it in or go second trace value. So I'd put it directly into the equation and solve it. But if it's a whole number, it's really easy. You could go to your table of values. You could second trace value. You could punch it in. If I say algebraically and you go to your calculator, that's a problem, right? Because that's technology. That's not algebraically. So 9 hours. What did we get dt to be? Sorry? 14.9 meters. Thank you. On the diploma and on your unit test, they'll always tell you what to round to. Has to give rounding rules. They can't not. If I didn't give you a rounding rule and you rounded to something different, I can't mark docu marks because I didn't tell you what to round to. Okay? And you only round at the very last step, right? We never ever know where in math do we ever round until that very last answer. If you round before that, your numeric responses might be wrong. And you did all the work, but you just rounded early. So we don't want to do that. At what times during the day is the depth of water 15 meters? Now, I gave this question because I feel like it's not actually worded very correctly. During the day, during that whole day, or during daytime? And what is daytime, right? That's a terribly worded question because what is day? Day could be anything, right? So how would this be worded better? At what times during the first 24 hours past midnight? That would be a better way of asking it, right? And what times during the first 24 hours, if you want to go that route, or the first 12 hours, if you want to do that. So during the first 24 hours. So in this case, you're going to get a whole bunch of answers, right? A lot of answers. So what could be the best way to ask this question? Instead of saying at what times, because how many times are there? Lots. They could ask you how many times is the depth of water 15 meters in the first 24 hours? And then you'd have to count how many times it crosses to give you that, so how many times. They could also say, when's the first time it reaches 15 meters? And that would get you one answer. Or they could say, when is the first time it falls below 15 meters? And then they're actually asking you for the second intersection. They can ask in so many different ways, right? So the way I'm going to ask it is at what times, instead of at what times during the first 24 hours of the depth of 50 meters, how many times? Because I don't want you to sit there and write out how many times, like all of the different times, because that's just crazy. They would never make you do that. So how many times is it? How many times does it cross? Now, does that actually happen because it's 15 meters? No. I have people who do that, and I get the same question on tests. They're like, if it's 7 meters, it must cross 7 times. And I'm like, no, it just happened to be the same number. Please don't correlate that. Okay. For how long is the depth of water greater than 12 meters in the first, I'm going to be nice, 6 hours? So how do we do this? You are going to get it crossing, let me see. Thank you. Yeah. So, 12 meters. I need to download my thing again. It went away, my calculator on my screen. So actually, I'm going to do the first for easy sake. To the 6 hours, I'm going to make it be 4. The reason why I don't want to do 6 hours is it partially is above at 6 hours, and I want to make it be an easy one. So here it says, is the water greater than 12 meters? So it's greater than 12 meters if you're looking here. From 0 to this cross section, correct? And then from this cross section to this cross section. So how could we figure out that amount? We'd have to find t of this one, the furthest one, and subtract it from t of this one, and then you'll find the difference in the hours between those two. And then you have to find the cross of this one, and that subtract 0, but let's just assume distance. And then add the two values together. So you take the furthest one, subtract this one here, and then figure out this value, and you have to add them together, because that's the time where it's above in the first 4 hours. So try it out. How much, sorry? 2.4 hours. Okay, today for homework you'll have all the ones where you're given the equation, and then tomorrow we're doing one where you're not given the equation, and then you have to practice those ones. So you're given a word problem, and you have to come up with the equation.